Dr. Tan, there are certain members of the vitamin E family that are called tocotrienols. Did I get that
That's
right?
right. That you got it right.
Could you explain exactly what tocotrienols are?
Tocotrienols are part of the vitamin E family, and the more popular one is known as tocopherol, and this is the less known cousins. The difference between a tocopherol, which you can find on a cereal box, compared to tocotrienols are two things. They, the structure of a vitamin E look like a picture of a sperm. It has a head and a tail. A tocopherol will have a bigger head and a longer tail. A tocotrienol would have a smaller head and a shorter tail.
That's the molecular
That is the
difference.
molecular difference
Okay.
between the two. And, the significance and the meaning of this difference is that the head is the part that all of us know makes it a powerful antioxidant.
So it's an antioxidant, just
Yeah.
like the tocopherol is.
Yeah, both of them are antioxidant.
Okay.
And then the difference lie in the nuances of the size of the head and the shortness of the tail in that of the tocotrienol. In the tocopherol, the antioxidant protection while in the head, because the head is smaller, is not able to move about and be more viable when they land on the biomembranes of the cell. So when people know that it's a powerful antioxidant, the reason it's a powerful antioxidant, it protects the membrane of the cell where there are lipids and fat. And in every human body, there are 75 trillion cells. It's a lot of cells, you know.
Yes.
And then the tail, like an anchor in a boat, sticks into the biomembrane and holds the head, which is antioxidant, in place. So people don't spend enough time to explain how is an antioxidant. Now, in that of a tocotrienol, the tail is shorter.
Okay.
So therefore, it doesn't sink into the biomembrane as deep. So it is much more mobile. So I describe to people this way, that a tocopherol is like a local policeman. It captured the bad guys in a particular township. But a tocotrienol is like a state trooper. It's able to cross the entire boundary for the whole state, so it covers a much larger surface area to capture the bad guys.
And how recently was this discovered?
This
Because
was,
vitamin E has been around for a long time.
that is right. Vitamin E, as in alpha tocopherol, was discovered at UC Berkeley in 1922. And tocotrienol was actually accidentally discovered some 30 years after, in the 50s.
All right.
And when they first discovered this, in those early days, they looked like dots on a little piece of paper, almost like shadows of the tocopherol. And then in the tocopherol, we have 4 tocopherols with 4 Greek words: alpha, beta, delta, and gamma. And the same with tocotrienol. But before the discovery, they'll have these 4 dots: alpha, beta, delta, gamma, tocopherol, and then they have a shadow dots behind it. And they thought that they did something wrong, like you develop a film. And then later they found out that these shadows were not tocopherol, that they did anything wrong. That was in about middle of 1950s. And then they found out that they were in fact tocotrienol, and structurally very similar, but not tocopherols.
So these tocos, we can call them, they are more powerful as an antioxidant than the original tocopherols.
Yes, and this too came out from UC Berkeley, from the famous antioxidant professor Lester Packer. And he found out that because it's able to travel, first he showed that the tocotrienol was about 50 times more potent antioxidant.
50 times?
50 times.
These
Now,
little shadows.
This is shadows. That was
Okay.
50 times. And obviously when it's 50 times, usually you think of something better, like 50% better. So when it's 50 times better, there's got to be an underlying reason. Otherwise, it would seem not plausible or believable. And he found out that the reason it was 50 times more potent as an antioxidant is because it doesn't stay in the same spot or move about slowly like the tocopherols would. It moves much more rapidly through the entire membranes of the molecule. Think of a cell like a lima bean. See, it's got 3-dimensional shape. So the lipid membrane is all around the whole cell. It's not a flat, and it's not a line, but it's actually 3-dimensional. So if a molecule is able to spin all around to protect it as an antioxidant, then it will be more powerful, as it would be something that stays in the same spot. Now, this said, this is not a place to say that alpha tocopherol is not good.
Okay.
It just have a longer tail and less potent as an antioxidant.
Less potent, but still good.
Still good, yes.
Thank you, Dr. Tan.